That is a nitric acid sulfuric acid, which makes a nitronium ion, which is electrophile. Amine is an activator. It's also para-directors. So if you don't know it, then you're probably going to put this nitro either also or para position, right? Then I've been telling you that no, that is not right, because when you do all reactions, this will protonate the ammonium groups, and then that becomes the meta-directors, nitro groups to the meta position. So that is a reaction that we talked about many times. These things may not go as you want. What if you want to make a nitro or a para position also positions? Then how are you going to do it? If you're going to use it, this is what you get. You're never going to get this. Plus, that doesn't mean that this cannot be created. We can create that in other ways. So how do we make it create in other ways? Is making this amine acylated. Now remember this reaction. Amine reacted with the acid chloride. What happened was this makes an attack, electron pair is going to go up, it's going to come back down, kick this chlorine groups out, so we got the amide form. When you make an amide, one thing that you want to know the amide, these nitrogen lone pairs on amide is no longer basic because it makes a resonance structure with the porphyrin so much, so that's not going to act as a base. Yet amide is still a lone pair, so this is going to be ortho para-directors. So once you convert amine into amide, then it only becomes an activator, even at a strong acidic condition. That strong acidic condition will not protonate out, so it becomes activators, so it's either ortho or para positions. I'm just using a para position here. The thing is, at the end of the reaction, we have to get rid of this acyl chain. That will be discussed in depth later, but that can be done by cooking up with acidic water. There's proton is a very strong, like a sulfuric acid, hydrochloric acid, water, that you can clean that away. We'll discuss the mechanism later. So this is a kind of a detour of making electrophilic aromatic substitution reaction using an amine becomes also para-directors. So this is something that you have seen before, protecting group strategies. We cannot protect an amine, so that way it does not become an ammonium group. So we carry out the reaction and then we take it away. So acyl chain acylations, this kind of becomes a protecting group for the amine. So this is kind of some kind of trick that we play that I want to show here. Some of you think that amine with such a strong reagents like the sulfuric acid, nitric acid is the only problem that you may ever get. Even that reaction can suffer. This is a Friedel-Crafts alkylation reactions, but in a way, the aluminum chloride, this Lewis acid, is used for Friedel-Crafts acylation as well. This amine, we are expecting this carbon-cation, and that goes either ortho para positions. But the thing is, one thing I want to point out that it is not happening, even though you get that. This is not happening. Why this reaction doesn't go? This is a base, this is acid. They actually make a complex like this. So free amine, if you're going to go for the Friedel-Crafts alkylation acylation reaction, then it will be trouble. You will not be able to do it. Just like the nitration reactions will have an issue. So amine becomes an issue many times. So what you do, you just learn the way. You make an acylation gun. That way, you create amine form. But now, this is no longer interacting with any of the acid. Proton or Lewis acid, doesn't matter. It's not going to react with it. So that can go for the Friedel-Crafts alkylation reaction. That becomes a para-directors. Then it goes here, right? And then we can get rid of that acyl chain by hydrolysis, which can be done by cooking with acidic water or sodium hydroxide. Either way, you get rid of that, then you get the alkylation done. So this is a kind of a protecting group strategy that we're talking about. Acyl group, acetyl groups, that's a protection of the amine, and then we get rid of that, that's called the deprotection. We get rid of that. So you have seen this thing a couple times before. Hydroxyl groups becomes an issue, then you can do that with single ether, right? We talked about the chapter 14. When the carbonyl of the ketones around the hydrogen becomes an issue, you can make this acetal, cycloacetal, right? When amine becomes an issue, you can do the radiation and get the amine. And then go reaction when you get rid of it.